Okay, everyone, I think this is recording right now. We are going to do a little video on rational functions. You just spent some time in these notes right here. We did this, sometime last week, and then towards the end of the week, you were doing all this stuff with finding x-intercepts and y-intercepts and vertical asymptotes and horizontal asymptotes, which is another specialized form of end behavior. So we are going to pick up this video right around here, okay, and I'm going to basically run through kind of two examples. We'll say 1.5 examples, and at that point, if you feel like you kind of got it and you just want to try your homework, you can. But if you are kind of stuck, then I would say watch the second part of the video and just make sure that things are kind of making sense here. So I am going to just come up with a random example here first, just based on some things that happened in our previous video. So if I gave you, and I'm just using my iPad to write here, and I don't have the program I would typically love to use on this yet, so I think eventually this will change. But if I had, oh, come on now. Well, we'll see, undo that, there we go. Okay, we're going to try again. If I have x squared, and you can just kind of write this off to the side if you need to, plus x minus 6, and I'm going to divide that by x minus 2. Okay, and we want to know what that is supposed to look like. We would go through all this work of what we did last week, so we'd probably want to put this in factored form. And if I put the numerator into factored form, I would get x plus 3 times an x minus 2 all over x minus 2. Okay, and when you were doing this last week, it was kind of new, and we said, oh, at x equals 2, there's actually a hole. And maybe what was not clearly defined is that what's left, in this case x plus 3, that's actually what this entire function looks like. So that really complicated thing that we started with actually is just x plus 3. It's actually just a line, and we know what that looks like. Okay, it is, we'd have a y-intercept at 3. Okay, and we would kind of just be at a slope of 1, so something kind of like that. But now what we know is at x equals 2, so 1, 2, if I go all the way up there, there's actually a gap there. There's a hole. Okay, so that's what that idea means, is there's just an opening right there where the function actually doesn't exist. And then I think in one of the answer keys, maybe I gave you a y value for that. I just want to talk about how we know what that y value is. We can basically take that value of x equals 2, where we know the hole is, and we're going to plug it in right there. We know that that function kind of models what's going on. So I can just take the x value where there's an issue and plug it into that simplified idea there. And so if we get 2 plus 3, we know that's 5. That's the y value. So the location of this hole is 2, 5, and that's going to work for more complicated sort of examples too. Okay, so I'm going to go back to, let's see here. First I want to perhaps delete this. Whoops. Ha! That's funny. I'm doing this on my laptop, and I should be doing that on my, there we go, on my iPad. Technology. I don't want to save that. I'm not sure what you're asking me there. I just want to do that. Alright, come on now. Don't laugh at me, I'm old. There we go. We're figured out. Alright. I'm going to go back to the PDF here because I want to talk through some things. Okay, here we have this equation here, okay, and we have it in the factored form. So what I want you to realize is they've done some work for you. Okay, to find the end behavior, they looked at the highest degrees here. Both are 2x squared, so if we divide those two things, we get 1. That's our end behavior. That's the horizontal asymptote. So they've done that for you already. Okay, they look at the factored form and say, oh, x minus 3, x minus 3, those cancel off. There's a hole at x equals 3. Okay, they looked at the denominator here and said, what's going to make this chunk equal 0? Remember, we don't care about the x minus 3 anymore. That's a hole. So they said, what's going to make that 0? That's going to be 2.5 or 5 halves. That's going to be a vertical asymptote. Okay, so we have all that filled in, and they're asking us to find the x-intercepts and the y-intercepts, and then basically graph it from there. Okay, so there's a few things that I want to add to that, so I'm going to go back to writing some things down, hopefully. There we go. Basically, if we took that simplified form now, so this is not the original, but if I took the simplified form after I cancel out the x minus 3's, I'm going to have 2 times x plus 3, and I'm dividing by 2x minus 5. Okay? And so if I want to know what's going on at that hole, let me do that in a different color here. Okay, what's going on at the hole? I need to say, let's plug an x equals, let's see, the hole is at 3. I need to plug a 3 into this simplified function. It's going to tell me the y value of the hole. Okay, so I'm going to have 2 times 3 plus 3 over 2 times 3 minus 5. And if I do all of that, let's see, 2 times 6 is 12, over 1, so that's at 12. Okay, so what this is telling me is the hole is actually at 3 comma 12. Okay, I would write that down, just a little bit more info where they're talking about the hole on the PDF. Okay, to find your x-intercepts, that's where the denominator equals 0. So I need to take the what's left over. Let's see, and I'm sorry, I'm thinking vertical asymptotes. Where the x-intercepts is where the numerator equals 0. So I'm going to take that 2 times x plus 3, and I want that to equal 0. Okay, and that's going to happen when x equals negative 3. So at x equals 3, there's a vertical asymptote, but at x equals negative 3, there is an x-intercept. Okay, and then the last thing they want us to do is to find that y-intercept. So the y-intercept is what happens when I plug a 0 for all the x's. So if I go to the very original, which is on your copy, so not really the simplified version, although the simplified version would still get you the same answer. That would still work technically. But if we did the original, okay, I'm going to have 2 times a 0 squared minus 18 divided by 2 times a 0 squared minus 11 times 0 plus 15. Okay, in the end, that just gets me negative 18 over 15, which is negative 1.2. Okay. Oops, let's see here. Let's be done with that. We can scroll up here. Okay, so now our goal is to take all of this info. Hopefully you wrote it down in your notes, and take all this info and try to get a sketch. So you have a nice graph. I have to kind of do it this way. Okay, but here's what I know. I know that the end behavior on either side is going to be at around 1. So over here it's going to be at a height of 1, and over here it has to end up at a height of 1. Okay, I don't know if it's going to be above or below or what it's going to do from there, but that's what I know. Okay, I know that at 2.5 there is a vertical asymptote. So if I were to count out to 2.5, I would have a vertical line kind of going down there like that. But then the other thing that I know is that at 3 comma 12 there's a hole. So really close to it, there's a hole right there. Okay. And then, let's see, I know the x-intercept and I know the y-intercept. The x-intercept was at negative 3, maybe somewhere right around there. And the y-intercept was at negative 1.2. And that's all the info that I know. Now, if that was not enough info, what I could do is test a few other points. And in later examples, I will do that. In this case, we actually have enough info. Okay, so you need to think a little bit about this. I'm just going to start on the left side. Okay, I know it's got to end up around this height right here. Okay, but it's got to get to this x-intercept. And if we think about multiplicities, multiplicities will still work with rational functions. So it has an odd multiplicity. It's going to go through. And that kind of makes sense because it's going to hit, it's going through there. It's got to hit that y-intercept, and it's going to continue through. Now, there's no other x-intercept right there, so it's not going to go back up. And it really can't run into that red line, so the only logical explanation is for it to kind of go down like that on that side. Okay, and then on the other side, on the right side, yeah, I know it's got to be at this kind of height right here. There's no x-intercept, so it really doesn't make sense for it to go down, but I do have this hole that it has to kind of pass through. So it's going to go up like that and then just trail up that vertical asymptote right there. Okay, so that is the example, or that's kind of what this graph would look like. Yeah, there is an arrow right here. It didn't quite come through, but it's just going to keep going up like that. Okay, so that is kind of the general idea for this. There are 2 more examples in our notes, and I do plan on creating a video that will go through those. If you think you kind of have a handle on that and you just want to give the homework a try, go for it. But if you run into some tricky ones and you're not quite sure what to do with it, go back and watch the second video. And if you're just kind of feeling like, this seems kind of difficult, definitely go back and watch the second video before you start the homework.